Greetings. In this video, we are going to continue solving this paper. So the last time we had this paper, we solved the first section, which is section A. So today we move on to section B. Section B, answer all questions in this section. Write your answers in the spaces provided in the question paper. Question B1, the question reads, the following diagram shows a distance time graph of a bus moving from town A to town B. Okay, so we are given the graph here. So in the vertical axis, we can see the distance in kilometers. In the horizontal axis, we can also see time in hours. Question B1A, the question reads, what is the total distance between town A and town B? What is the total distance between town A and town B? Okay, so here we don't need to stress ourselves. There is no need for us to start doing calculations here. So the one thing that we need to do is to locate the corresponding value. So we can see that this bus started moving from point A, or from town A up to town B. Okay, then here we are given the numbers. We are given the numbers representing the distance. So we can see that here we have 50. Here we have 50, and we can see that the corresponding value is somewhere between 58 and 59, as we can see here, the corresponding value to town B. So town B is the end point, or town B is the destination of this journey. So since we are saying the distance is between 58 and 59, so we are going to choose 58. So we are going to say 58 kilometers. So we have answered the first question. Let us move to the next question, which is question B1B. Question B1B, the question reads, the bus stopped at a station between town A and town B. For how long did the bus stop at this station? Okay, so we are told that before the bus reached this station, which is station B, the bus stopped within the journey, or within the trip. So we are asked to give the time it took for this bus to be at this station. Okay, so what are we going to do to find the time? So to find the time, let us make use of the information given here. We have the information given here. Okay, so we need to understand that the this slope represent uniform speed. Let me use this one so that we can understand better. Okay, so we are going to use this one. So the gradient represent the uniform speed. The gradient represent the uniform speed. The flat line represent station or stopped. Then the steeper line, or the slope, represent faster, or acceleration, or speed. Represent faster or speed. Okay, or speed. Then this one represent negative gradient, or returning to station, or we can come back to this one. Okay, so we have seen that uh, a flat line represent station or stopped, represent station or stopped. So what are we gonna do to find the time it took for this bus to be at this station, or the time the bus stopped at the station? So what we'll do, we are going to say the bus started the bus stopped at when the bus stopped when the time was 2.2 hours. Okay, 2.2 hours up to 3 hours. Okay, so what are we going to do? We are going to say, we are going to say 3 hours. We are going to say 3 hours minus 2.2 hours. We are going to get 0.8 hours. So for the car stopped for 0.8 hours. So as we can see, the time here has been given in hours, so no compromise here. So we need to give our time in hours, so there is no need for us to start changing time from hours to minutes or from hours to seconds. So therefore, the time it took for this bus to be at this station is 0.8 hours. Without wasting time, let us move to the next question, which is the question C. Calculate the speed of the bus between town A and the first station. Calculate the speed of the bus between town A and the first station. So where can we see the first station? Where can we find the first station? So the first station is found here. So this is our first station, and we are told to find what? To find the speed. To find the speed. To find the speed of the bus between town A and the first station. So this is our first station. So the first thing that we are going to do here is to come up with the data collection. What have we been given? Okay, so before we come up with data collection, this is the formula that we are going to use. So we are going to say speed is equal to distance divided by time. Okay, so this is the formula that we are going to utilize. So data collection, what have we been given according to our graph or according to our question? So as we can see, we are given distance. So the distance covered before the first station was 30 kilometers, as we can see here, 30 kilometers. So the corresponding value here, if we zoom in this graph, the corresponding value is 30 kilometers. So the distance it covered before the first station is 30 kilometers. Then let us also look at time. The time in the previous question we said it stopped when the time was 2.2 hours. When the time was 2.2 hours. When the time was 2.2 hours. Okay, so we have distance and we have time. Now let us see, devise the formula. So this is the formula that we are going to use. So we are going to say speed is equal to distance divided by time. Divided by time. Okay, so we are going to say speed is equal to the distance is 30 kilometers over time. Time is 2.2. So we are going to say 30 divided by 2.2. 30 divided by 2.2. You are free to pause the video and use your calculator. So this is science. We are permitted to use our calculators. We are permitted to use our calculators. So uh, if we say I'm trying to use my calculator, I can't find my calculator. Okay. Okay. So yeah, so if we say 30 divide by 2.2, we are going to get 3 point, let me do this. We are going to get 3.64 kilometers. So this is our answer. So therefore the speed of the bus between town A and the first station is 13.64 kilometer per hour. So remember, you need to include the units in order for you to attract 2 marks. So without including the units, you won't attract 2 marks. We move to question D. Calculate the average speed for the O journey. Calculate the average speed for the O journey. So they want us to calculate the speed of the bus for the O journey. So what are we going to do? We are going to find the overall. We are going to find the overall distance or the total distance over total time. Okay, over total time. So the bus stopped here. As we can see, the bus stopped here. So this is where the bus stopped. This is where the bus stopped. And the total distance is 58. So we found this one in the first question. The total distance is 58. Then the total time is 4 hours. So it took 4 hours for this bus to reach at the town B. Okay, to reach at town B. So this is the formula that we are going to use again. We are going to say average speed is equal to total distance divided by total time. Data collection. So the total distance is 58 kilometers. The total time is 4 hours. Now let us plug in the values in the formula. Okay, in the formula, so we are going to say speed. We are going to say speed is equal to distance. So the distance we have here is 58 kilometers. Then time, so the time is 4 hours. The time is 4 hours. So if we say 58 divide by 4, you are free to use your calculator. 58 divide by 4, we are going to get 14.5 kilometers per hour. 14 kilometers per hour. Okay, let us move